So this video is going to go over some applications of when you will see these rational functions in real life. So here's an example. Companies planning to manufacture wheelchairs that are light, fast, and beautiful. The fixed monthly cost to make these wheelchairs is $500,000, and it will cost $400 to produce each of these new radically innovative chairs. All right, write the cost function, C, of producing X number of wheelchairs. So my cost function, we're going to have our fixed costs every month of $500,000. That's going to pay for the building, the electricity, the people, the benefits, the blah, blah, blah. So everything that I need to make my company run. Plus, I'm going to have some variable costs that go with buying the raw materials to make the wheelchair. And that's going to cost me $400 per chair. So there is my cost function with my fixed costs plus my variable costs. All right, then it says write the average cost function of producing the chairs. Well, how do you find an average? You take the total and you divide it by the number of things. So in this case, the number of wheelchairs. So we're going to take that cost function and we're going to divide it by X, right, to find the average cost for each wheelchair. Notice that is a rational function. Right, so we can expound upon this by digging a little bit deeper into this cost function. So using that cost function that we just found, find and interpret what each of these things mean. So the first one says cost function, the average cost function at 1,000. So what that means is we are going to find the average cost to make a wheelchair if we make 1,000 wheelchairs. So you're going to plug that into your function. So you're going to take 500,000 plus 400 times 1,000. And then divide that by 1,000. So we can just plug all that in our calculator, and we end up getting 900. So that means if we only make 1,000 wheelchairs, we are going to have to charge people $900 per wheelchair in order for us to break even every month. Okay, so it's kind of an expensive wheelchair, right? $900 is a lot of money. So what happens if I up that? What happens if I make 10,000 wheelchairs every month? What will the average cost then be for that wheelchair? So same thing, you're going to plug 10,000 into your average cost function. So you're going to plug that in and divide by 10,000 this time. And when you plug that in, that is going to give you a cost of $450. So if I make 10,000 wheelchairs every month, I can charge $450 and my company will break even. I won't make any profits, but I'll break even. All right, and the average cost of 100,000. So we're going to make 100,000 wheelchairs every month. So just going to repeat the process, take that average cost function. We're going to plug in 100,000 this time. Divide by 100,000. There we go. And when you put that in there, you get 405. So if I make 100,000 wheelchairs every month, I can charge $405 and I would break even. All right, so digging a little bit deeper into the same example. Find the horizontal asymptote for the average cost function. Okay, so if we look at the average cost function, we know we can find the horizontal asymptote. They have the same degree in the numerator and the denominator. So my horizontal asymptote is going to be y equals, and it's going to be the ratio of those leading coefficients. So 400 over 1. So we're going to have a horizontal asymptote at y equals $400. What does that mean in terms of the company? So obviously our function's never going to cross that because at the bare minimum it takes us $400 in just the cost to buy the materials, right, for the wheelchair. And that means I can't, if I charged $400, I wouldn't be able to pay that $500,000 every month for my fixed costs. So I can get it really, really close to $400 if I build a lot of wheelchairs every single month. But I can never actually hit $400. So my wheelchair cost will approach $400 as more and more wheelchairs are produced. And as you can see, we saw that in the last slide, right? We started at 900 and then we made more. We got it down to 450 and then we made more. We got into 405. So if we made more, we could get it even closer to 400, but we're never actually going to be 400 because we have that horizontal asymptote there. So that's a great way that you can see the use of rational functions when we talk about business applications. Okay, so here's another example. All right, so if you'd like to, this is just like the last one. So if you want to press pause and see if you can figure it out yourself, feel free to do that. All right, so let's see how you did. All right, so write the average cost function for for producing these shoes. All right, so my cost function is going to be my fixed costs, which are the $300,000. Whoops, $300,000. Plus my variable cost, which is 30 times X. So $30 for the raw materials to do each pair of shoes. All right, write the average cost function, which today called Z. So Z of X is going to be that cost function, so 300,000 plus 30X, and we're going to divide it by X. So there is my average cost function. So it says find and interpret Z of 10,000. So if I make 10,000 pairs of shoes, right, again, this is every month, I'm going to plug that in, so 300,000 plus 30 times 10,000, and then all that divided by 10,000, and you should get $60. So if I make 10,000 pairs of shoes each month, I can charge $60 and my company will break even. All right, then it says do the same thing for 100. What happens if I make 100,000 pairs of shoes every month? All right, so we're just going to do the same thing, plug it into that average cost function. So 30 times 100,000 this time, and then divide it by 100,000. And that turns out to be $33. All right, and part D, what is the horizontal asymptote? Again, look at your average cost function. Degree is the same in the numerator and the denominator, so my horizontal asymptote is going to be y of 30 over 1, right? Take that ratio of the leading coefficients. So we're going to have a horizontal asymptote at y equals 30, and what does that mean? Describe it in terms. So that means the cost to produce each pair of shoes is going to approach $30. But as more and more shoes are produced, but we're never actually going to get it down to 30, right? Because that's the cost that would just cover the materials for the shoe. So again, great example of a business application for this. Okay, another place that you could see this is going to be if you take a pre-calc or a calculus class, you are going to run into what's called the difference quotient. The difference quotient is a rational function. And it's this formula right here. If you've never seen it before, let me get my highlighter out. It's this one right here. This is my difference quotient. All right, we're not going to talk about what it is or what it does, but that's a whole nother story. But we are going to find it using this function f of x. So we need to know f of x. We need to know f of x plus h. So let's focus on finding that first. What is f of x plus h? So I'm going to take my function x, and every place I see an h, I'm going to put an x plus h. So that tells me f of x plus h is 2x plus 2h plus 3. Okay, so now I'm going to put it into this rational equation. So we're going to start with f of x plus h. We're going to subtract the function f of x, and then we're going to divide everything by h. So f of x plus h is 2x plus 2h plus 3. And we're going to subtract the whole function f of x, which is 2x plus 3. So we're going to subtract all of that, and then we're going to divide it by h. So notice I can distribute that negative sign. So my numerator is going to become 2x plus 2h plus 3 minus 2x minus 3 all over h. See if we can clean up that numerator. Notice the 2x's. Negative 2x plus 2x is 0. And then positive 3 minus 3 is going to be 0. So I'm left with 2h over h. And 2h divided by h is 2. So your difference quotient for f of x is 2. And when you get to calculus and pre-calc, you will talk about what that actually means. But we're not going to talk about that in this class. But you will see this again if you take pre-calc or calculus. All right, so here's a more challenging one. Same difference quotient, same thing. But this time we need to find the difference quotient for this function, f of x equals x squared plus 2x plus 3. So again, first thing we need to find is that f of x plus h. So everywhere I see an x, I'm going to x plus h. So x plus h squared plus 2 times x plus h plus 3. So I need to clean all that up. So I'm going to square that binomial, which is going to give me x squared plus 2xh plus h squared. and then get rid of the parentheses here, so 2x plus 2h and plus 3. And I don't see any like terms that I can put together, so that is good. So there's my f of x plus h. All right, so we need to find f of x plus h minus f of x all over h. Okay, so this is going to be a long problem. So I'm going to take that first function, so the f of x plus h, which is x squared, plus 2xh plus h squared, plus 2x plus 2h plus 3. And we're going to subtract this entire function, right? We're going to subtract f of x. So if it's okay with you guys, I'm just going to subtract it and get rid of the parentheses right now. So I'm going to subtract the x squared. I'm going to subtract the 2x. I'm going to subtract the 3. And I'll put that all over h. So if it does help, you might want to write it without the parentheses first, but I just find it's just a subtraction. It's not too bad to just go ahead and get rid of those parentheses right away. All right, so let's see what I can get rid of. Okay, so I've got an x squared minus x squared, that adds up to 0. Positive 2x and negative 2x, that adds up to 0. And positive 3 and negative 3, that adds up to 0. All right, so I am left with 2xh plus h squared plus 2h all over h. Notice all of those terms have an h, so I can factor that out of each term. So that leaves me with 2x plus h plus 2. So there is your difference quotient for that particular function f of x. All right, so you will see applications in other places. You will also see applications in other math courses that you will see down the road. So hopefully that helped. So yeah, you will see lots of other applications. So we will talk more about other things that you can do with rational equations coming up here in the next video. So make sure you stick around.